Good morning to all conference participants. The topic of our presentation is feature of format salt balance in rice fields with various parameters and designs of the Danube rice irrigation systems. Rice system belongs to specific irrigation systems. The specificity is caused by the growing conditions of the leading crop of crop rotation, flooded rice, which irrigates by using surface flooding. Also have the effect the complex hydrogeological conditions of area of rice system and the presence of lands prone to salinization. The total area of rice irrigation system in Ukraine is over 62,000 hectares. The largest area concentrated in the Crimea, Kherson and Odessa regions. Today, the modern rice irrigation system is a complex set of water supply, drainage, regulative, and another elements connected by a single technological process in combination with the rice fields. How well the design of the fields is chosen and its parameters selected depends on how successfully it will perform its functions. Construction features of irrigation fields and their parameters, such as distance between the drains and depth of the drainage network, affect the intensity of the process, the salinization of soils and groundwater. According to the results of long-term studies of drainage network operation efficiency, determining that drainage on the saline lands of rice system must meet a number of requirements, compliance with which will ensure the formation of optimal salt, water and air regime for rice and related crops of crop rotation. Research by a number of authors showed that the salinization effect of the drainage network of the rice fields cannot be estimated only by the amount of salt carried throughout it. Objective assessment of the drainage network can be obtained by drawing up the salt balance, which would take into account change in salt reserves in soils, groundwater, also in flows of salts with irrigation water and their removal with drainage water, and another components of both income and expendable part of such a balance. Studies of salt balance were conducted by us for 5 years in order to assess the effectiveness of rice fields with various parameters and designs on the Danube rice irrigation systems located in the Odessa regions. As the object of research was selected the Kilia rice irrigation system, which located in the territory of saline East Kilia floods of the Danube Delta. The total area of Kilia rice irrigation system is 3.45 thousand hectares. Kilia rice irrigation system was built according to the well-known two schemes of irrigation carts. The first one is Krasnodar-type cart. Abbreviation used on slide is KTC, and second one is cart check with drainage. Abbreviation used on slide is CCD, with one side and two side command. The distance between the drainage channels depended on the soils and hydrogeological conditions, and it's from 200 to 500 meters. So, according to such design features, for the study of the cell balance formation in the rice fields with various parameters and designs, we had selected 3 different experimental sites. The first site consisted of 2 cart checks with drainage with a one-way command irrigator discharge and distance between the drains 200 meters. As a control was considered Krasnodar-type cart with a 2-way command cart irrigators and distance between the drains 200 meters. The second site also consisted of 2 cart check with drainage and Krasnodar-type cart, but the distance between the drains was 250 meters. And the third site consisted of 2 cart checks with drainage with one-way command irrigator discharge and the distance between the drains for the first one is 250 meters and for the second one 500 meters. The salt balances were compiled for 3 meta layers of soil and groundwater for each of the fields during the period of rice cultivation on them and based on water balance data. Many years field studies conducted by us and another scientist on the Danube rice irrigation systems showed that exist some features of filtration strip motion on irrigation carts during the period of water layer maintenance. This feature related with the formation of 3 characteristic zones. The first one is zone of groundwater lifting, located along the irrigation channels. The next one is stagnant zone, located in the center of the checks. And the last one is the zone of active filtration. This zone located along the drainage channels. The presence of such zones indicate irregular drainage of the irrigation carts area. The total area that practically doesn't drainage is more than 60% of the irrigation carts area. On the basis of annual salt balances were complied average salt balances for fields of various parameters and designs. Analysis of salt balances was carried out by assessing the structure and dynamics of their main components. In income part were considered reserves of salts in the soil layer 1.8 meters and in the groundwater layer 1.2 meters in April. Receipt of salts with irrigation water and with fertilizers, and also considered total salts balance in the layer of 3 meters. In expendable part were considered reserves of salts in the soil layer 1.8 meters and in the groundwater layer 1.2 meters in November, removal of salts with drainage water, with wastewater and with the harvest. Also were considered salt exchange with the lower horizon and total salts in the balance layer 3 meters. Comparison of the amount of salts removed with drainage runoff on the cart check with drainage and Krasnodar-type cart with distance between the drains 200 meters and 250 meters showed a significant advantage of cart check with drainage. The main reason for the better removal of salt with drainage runoff on the cart check with drainage is the presence of irrigator discharge, which played the role of shovel drain during the part of the irrigation seasons. The amount of salts removed by the irrigator discharge was up to almost 15% of the total amount of salts removed from the cart check with drainage by the whole drainage network. If on the cart check with drainage along the irrigator discharge observed desalinization of soils and groundwater, then on Krasnodar-type cart in the central part there was a contrary process, salinization. These facts indicate that there is a significant advantage of cart checks with drainage over Krasnodar-type cart in terms of ensuring optimal salt regimes. The conclusions of the study are shown on the slide. As the main idea, it was noting the following. Comparing cart check with drainage and Krasnodar-type with the same parameters, the better desalinization effect can be achieved at the cart with drainage. But in the case of a distance between the drains 400 meters, it's impossible to achieve a high rates of soils and groundwater desalinization, even at a cart check with drainage. Therefore, such cart check with drainage should be reconstructed to cart check with drainage with distance between drains 250 meters. More detailed information you can find in the other article. Thank you for your attention.